Good morning to all. So in the previous sessions, we have started with unit number 4 and we understood what is Maxwell's equation, and we also understood what is Poynting theorem and how the power flow in the coaxial cable, those topics we have understood. Today we are going to start with unit number 3 problems. So here we are going to do some 20 problems in unit number 3 and for the 2 days, today and tomorrow. And after that we will start unit number 4. Let me start with unit number 3. So the first problem, given point C, the point is 5 minus 2 3 and P 4 minus 1 2 3. A current element ideal value is given in terms of amp meter at C. So the current element is located at C, produces a magnetic field. So we have to find the DH vector, magnitude of the same, and unit vector. That is our problem. So for finding that thing, we have to apply the Biot-Savart law. So Biot-Savart law is given by DH is equal to ideal divided by 4 pi r square cross AR vector. So for finding AR vector, let me understand R vector. So we know that whenever we have to find the magnetic field, we have to find the magnetic field at that point. So we have to minus that point with the given magnetic field potential. So therefore, the point at which we are going to find the magnetic field is at P, and therefore 4 minus 1 and 2, and it should be minus with this particular value. So therefore R vector is equal to 4 minus 5 minus 1 plus 2 AY 2 minus 3 AZ. So that is the value, and the answer is minus AX plus AY minus AZ. If I want to take the modulus, if I take root of minus 1 square minus 1 square, it happens to be root 3. So that is the answer for root 3. So we have ideal, we obtain R vector. From here AR vector is equal to R vector divided by modulus of R, and therefore it happens to be 4 pi R square 4 pi root 3 power cube, it is cube. And hence all the constant will be evaluated as 1.53 micro, and these two are cross product. So in order to evaluate the cross product, we have to make a determinant. So it is a determinant. After expanding the determinant, I'll get this answer as 1.53 cross micro 2AX plus 3AY plus AZ. That is DH vector. If I want to find modulus, I have to take the magnitude. So this is a common value we are taking outside, and 2 square, 3 square, 1 square happens to be 5.7 micro amp per meter. So I have to find the unit vector. So in order to find the unit vector, I know unit vector for H is equal to DH divided by modulus of DH vector. So DH is obtained here, modulus of DH is obtained here. So if I do this thing, and this will get cancelled. So therefore this value divided by this value, which is nothing but root 14, and if I expand that, you will get the answer as 0.5 AX plus 0.5 AY plus 0.27 AZ. Second problem, here H vector is given. We have to find the magnetic flux, and the surface is defined. The surface is, it is a variable of phi and Z. If the surface is varying with reference to phi and Z, we can clearly understand R is equal to constant. Let me do the problem. So for finding the flux, this is the main formula. Psi is equal to double integral B dot ds. It is the original formula. So we have to find B vector and ds vector. So B vector is equal to, already H vector is given. If I want to find the B vector, we know the formula. B vector is equal to mu H vector. So since it is no medium is specified, we are taking R medium mu naught, 4 pi into 10 to the power of minus 7 with that value, H vector value, and therefore the answer is 3 by R cos pi AR vector, and psi is equal to double integral of B vector dot ds. So if I take a cylindrical coordinate system, there are 3 areas. So out of which here there is AR vector. So I know for this given region R is constant. So therefore for this surface AR is a vector, and therefore corresponding area is R d phi dz. If I expand this, I will get double integral 3 cos pi d phi dz, and we can understand from the given integral limit, I can substitute pi is equal to 0 to pi by 4, 0 to 1. If I do that, the integration for 3 is constant, we are taking outside. If I do the integration for cos pi, it is sin pi 0 to pi by 4, and if I do the integration for z dz, it will become z. So for that 0 to 1, if I apply all the limits, I will get the answer as 2.12 Webers. And in the third problem, they are given the question is we have to find the flux, and the portion is defined. One is constant, pi is equal to pi by 4 is constant, and the region is defined by r running from 0.01 to 0.05. Z runs from 0 to 2. So if I take the current I is given 2 ampere. The direction of the current flow, it is flowing inside the conductor, and the direction is Z axis. So A is the direction. So for that, we have to find the B vector. I can understand B vector is equal to mu naught H, which we solved in the second case, and H vector is equal to I divided by 2 pi R. So I is given, R is given, we can able to do the problem. So psi is equal to double integral B vector dot ds. So therefore psi is equal to, from the given statement, 0.01 to 0.05, Z is equal to 0 to 2, and for mu naught I is equal to 2 pi R. R is given, but it is given as a limit range. So the range is 0.01 to 0.05, and therefore if we keep on doing the integration, 1 by R will become log R. If I do the integration for dz, it will become z. Limit substitution, I will get psi is equal to 1.21 microweber. And next, fourth problem. The fourth problem is the case of a straight conductor, a finite conductor. So here the current is given 0.4 ampere in a z direction. So here the current is passing in z direction, and the point is defined. In the conductor, one point is defined, which is 2 comma minus 4 comma 0. We have to find H vector at 0 comma 1 comma 0. If the filament lies in the interval, they are given free interval, in which the first interval is an infinite case, second interval is a semi-infinite case, and the third interval is a finite case, since it is running from finite values. So for the first solution, for infinite case, we got the answer as H vector is equal to I divided by 2 pi R A phi direction. So with that knowledge, we have to find R vector. So we know I have to find H vector at 0 comma 1 comma 0. So therefore always R vector will be 0 comma the point at which we are going to find the magnetic flux, that point minus a point in the conductor, which is 2 comma minus 4 comma 0. So therefore R vector is equal to minus 2ax plus 5ay. If I want to find the modulus of R is equal to 2 square plus 5 square, which happens to be root 29. So for time being, let us calculate pi is equal to tan inverse of pi by 2 for time being, which we are calculating. So which is 68 degree, and H vector is equal to I known value 2 pi R written here. R is equal to root 29 a pi, and the answer is 0.011 a phi ampere per meter. This is the answer, but still sometimes there may be a chance of asking the H vector in Cartesian coordinates. In that scenario, we have to find Hx vector, Hy, and Hz. For finding Hx vector, Hx is equal to H vector dot Ax direction. For finding Hy, H vector dot Ay. For Hz, it is Hz dot Az. And hence, we are writing H vector we obtained here in the direction of A phi dot Ax. So A phi dot Ax will happens to be minus sin phi. With the unit number 1, we can understand the A phi dot Ax is equal to minus sin phi, and phi is evaluated here. With this those substitution, we will get the answer as minus 11 into 10 to the power of minus 3, and hence we will find Hy and we will find Hz. For Hz, we can understand it is A phi dot Az. Since it is A phi dot Az, both are in same coordinate system. Since it is both are in same coordinate system, which dot product, the answer always become 0. And with this scenario, H vector in cylindrical, and this is H vector in Cartesian. So that is the first case. And from the first case, I can evaluate the second case. So it is infinite, and this is semi-infinite case. Since that is a semi-infinite case, if I divide the answer by 2, I will get the B answer. So therefore B is equal to, if I divide by 2, the answer is roughly 0.006 A phi A by A ampere per meter. So the third case, we know the third case is running from minus 3 to plus 3, and for that case we have to write the H vector formula. If you recall the derivation, we derived H vector is equal to I divided by 4 pi R cos alpha 1 plus cos alpha 2 A by A ampere per meter. So here I is known, R is known, but we have to evaluate alpha 1 and alpha 2. For that thing, we are making a conductor, a small conductor running from minus 3 to plus 3. It is running from minus 3 to plus 3, which the distance between that is 3 and 3. Since the point is given 2 comma minus 4 comma 0, exactly it is perpendicular bisector, and the point of evaluation is 0 comma 1 comma 0, which is given in the problem. The distance between these two is, we have evaluated root 29. This is alpha 1 and alpha 2. With this given structure, I can find a given diagram. I can find alpha 1, which is tan inverse of opposite by adjacent root 29 by 3, which happens to be 60.87. Similarly, alpha 2, since it is a right angle, it is a triangle in which the center line is a perpendicular bisector. Alpha 1 and alpha 2 will be same, and alpha 2 is also 60.87 degree. So with those substitution, all the values are known. Substitute, and I will get the answer as H vector is equal to 5.75 milliampere per meter. That is the answer for this particular problem. So this is the fourth problem. And the fifth problem, if we go back, if we find the fifth problem, it is a problem based on equilateral triangle. So a triangle is given. So the triangle is drawn here, and the side of the triangle is 4 meter. So this is 4 meter. This full distance is 4, and this full distance is 4. And the current passing in the triangle is 5 ampere. So we can evaluate, we can think a problem such a way that it is one finite conductor, second finite conductor, and third finite conductor. So there are 3 finite conductors which have been joined to form a triangle, and therefore with that scenario, I will evaluate only one AB. If AB is found, we can say BC and CA will be same, and therefore the total H vector is equal to addition of all the 3. So all the 3 will be same because it is an equilateral triangle, and therefore we are evaluating HAB. So the same formula what we used in the previous problem, I known 5, 4, 5, R should be evaluated. If I take this diagram, so here the point is at the center. So we have to find at the center, the point is center, and between this it is a perpendicular bisector R. So 2 meter, equilateral triangle, angle is 60. If I draw a line here, if this is 60, this will become 30. So 30 degree, 2 meters, R should be evaluated. So for that, tan alpha is equal to R by 2. With help of this cosine formula or tan formula, R is equal to 2 by root 3. So substitute here 2 by root 3. Evaluation or substitution, you will get 0.6 A5, roughly 0.6 A5. If I multiply this with the 3 times, it will become 1.8 A5 ampere per meter. So this is a simple problem in which 3 conductors will be joined to make a triangle. So the next problem, 4 conductors will make a rectangle. That is a problem. So a rectangular loop 8 cross 4. I am taking this as 8 and this as 4, and running from A, B, C, D, carrying a current of 10 ampere. 10 ampere is flowing in the conductor. If the current is flowing in the conductor, there will be a magnetic field. We have to find the magnetic field at 4, 2, 0. So Z is 0. So don't bother about Z. You bother only about X and Y. So here from A to B, I am taking this is positive X, positive Y, and positive Z. So therefore 2 meter, 2 meter, 4 meter, 4 meter. So here there are 4 conductors. If I take AB conductor, and I can able to understand that it is 4, 2, 0. So 4, 2, 0. This is X axis 4. So that is a point 4. And from Y axis it is 2. So 2, it is a positive Y 2. So the point is here. So the point is located at B position. So therefore, it is a conductor, and the point is located at the B point, and we can obtain alpha 1 is equal to 0 and alpha 2 is equal to 180 degree. So with the same formula what we used in the previous case, I divided by 4 pi r cos alpha 1 plus cos alpha 2, it will become cos 0 become 1, cos 180 will become minus 1, 1 plus of minus 1 becomes 0, and yes, the complete solution is equal to 0. Similarly, if I take a BC point, so this is a BC point, again the point is lying at the B position, and therefore alpha 2 is equal to 0 and alpha 1 is equal to 180 degree. With thus constraint, I may understand that HBC will also become 0. Third condition, the DC. So from DC here, if I take the DC diagram, so this is a DC diagram given. So this is drawn slightly in this direction, and I know the point P is located exactly with a straight line, so straight line, so P. So the angle made at this point is alpha 1, and if I close this triangle, it will become alpha 2. R is equal to 8, R is equal to 8, and for here it is 4, DC is equal to 4, R is equal to 8, and DC is equal to 4. With all this triangular construction, I can find alpha 1 is equal to 90, alpha 2 is equal to tan inverse 8 by 4, which happens to be 63.4. So I known, R is known, alpha 1 known, alpha 2 is known. With all the substitution, I'll get the answer as 0.0445 ampere per meter. And as a final case, with reference to the first diagram, if I draw AD, the point will be exactly perpendicular to A, and we are keeping the point. If I join this point, it will become alpha 1, alpha 2. From the picture, I can write alpha 1 is equal to 90, alpha 2 is equal to, this is 8 as per the diagram, 8 as per the diagram, and R will be 4. With that substitution, you'll get 26.56 degree. With those values, we will get 0.78 or 0.178. If I add all the four, 0 plus 0 plus 0.0445 plus 0.178, the answer will be H is equal to 0.222 ampere per meter. Therefore, if I take the overall construction, the H vector is equal to 0.222 ampere per meter. Next problem. If you see the next problem, you will find the problem is in a circular structure, that is a conductor, a circular conductor. The two narrow circular coils, so coil A, coil B, common axis. So the center will be lying on the common axis and are placed 10 centimeter apart. The distance between these two is 10 centimeter. So coil A has 10 turns. So with the given data, N1 is equal to 10, R1 is equal to 5 centimeter, I1 is equal to 1 ampere. With the given data, N2 is equal to 1, R2 is equal to 7.5 centimeter, I2 is equal to a question mark, that is a question. So here they have given additional statement. If the magnetic field at the center of the coil A, is to be 0, what current should be flowing through the coil B? So I am going to find the magnetic field at the center of A. So this is a point where I am going to evaluate the magnetic field. So if I keep this point, the point is center, and for the second coil, it is away from 10 centimeter. So I have to find H1 and H2. If I combine those two, it will become 0. So first thing is H1 or HA. In the case of HA, since it is a circular conductor and the point is lying at the center of the disc, we know I by 2R. There are number of turns involved. N1 I1 divided by 2R1. Substitution 100 ampere per meter. And HB, if I take the coil HB, it is I2, the formula is this much, this amount, I2 R2 square divided by 2 R2 square plus Z square power 3 by 2. This is a formula for when the point is away from the disc on the axis, and I am writing this formula because for this diagram the point is here. But for this coil the point is here itself, and therefore the formula will differ and hence it is this formula. With this substitution, I doesn't know what is I2, so I am substituting I2 as it is. So I will get 1.44 I2. If I add those two, and I can give it the statement, if I add this two, it is equal to 0. So 100 plus 1.44 I2 is equal to 0, and hence with the substitution, I will get I2 is equal to minus 69 ampere. This minus is a very important concept, because if the current is flowing in clockwise direction, here the current will be in opposite direction, that is the indication. If that is clockwise, the second will be anti-clockwise. If the first one is anti-clockwise, the second will be clockwise. That is a given indication. So next problem. A wire carrying a current of 100 ampere is bent in the form of circle. Again, the problem is based on circle. The radius of the circle is 5 centimeter. Diameter is 10, radius is 5 centimeter. Calculate the magnetic field intensity at the center and magnetic flux density at the axis and at 12 centimeter from it. So first diagram is, if I am having a circle, I am placing a point at the center, and there I am going to find the electric field intensity. But for the second case, we have a circle. From the axis, the point is lying 12 centimeter apart, and we have to find the magnetic field. So for the first case, as per the previous diagram, previous problem, it is I by 2R. There is no N is involved because there is no number of turns given here. So it is I by 2R. For the second case, the equation is I R square divided by 2 R square plus Z square power 3 by 2. with all the values are given, substitute and get this answer. And we know I have to find the magnetic flux density. B is equal to mu naught H. Substitution, I'll get 1.3 millitesla. With the substitution for B on the axis 12 centimeter apart, B is equal to 0.071 millitesla. That is the answer for this problem. A simple problem. So given. Next problem, ninth problem. A circular loop. We are taking a circular loop, and suddenly they are given some equation. You can able to understand this is a circle equation. X square plus y square is equal to r square. So r is equal to 3 from this statement. Z is equal to 0 carries a current of 10 ampere along A5 direction. A5 direction. If the current is carried in A5 direction, flux will be in AZ direction. That is a known fact. Determine H vector at 0, 0, 5 and 0, 0, minus 5. We can understand it is a circular loop case, and the formula is I square 2 r square plus z square power 3 by 2. For the first case, I will substitute z is equal to plus 5. For the second case, we have to substitute z is equal to minus 5. If I make the minus 5 square, it happens to be 5 square. Both answer will be same, and the answer is 0.227 AZ ampere per meter. R is given, R is equal to 3, substitute R is equal to 3, I is equal to 10 ampere. 10 ampere. Next is a problem to find the current. So in the region is defined, R is equal to 0 to 0.5, cylindrical coordinates. A current density is defined, which is this amount of value at this region, otherwise it will become 0. So find the expression for H vector using Ampere's law. Before that, let me find I vector. I vector is equal to, since the current density is given, let we obtain a current. So current is equal to current density into area. Double integral. J vector is equal to this amount in AZ direction, and therefore ds should be some amount of value with the same AZ direction. So therefore AZ direction. So for AZ direction, the ds is r dr d phi. It is a well-known fact from unit number 1. Therefore pi is equal to 0 to 2 pi, r is equal to 0.0 to 0.5. If we do the integration, so this integration involves Bernoulli's formula or integration by parts, because it is r into e power minus 2r. So that is shown here. Integration of parts is shown here. You can able to find there is integration of parts, and substitution you will get I is equal to 1.8 ampere. With this 1.8 ampere, by using Ampere's law, integral h dot dl is equal to I. Integral dl will become 2 pi r, because I am taking a circular system. For circular system, length will become circumference 2 pi r 1.8676, and therefore h is equal to 2 pi r. If I bring the 2 pi r in the bottom, it will become 0.2972 by r A5, and that is a given region. Next problem, find H vector at this particular point in a coaxial cable, and this is a problem pertains to coaxial cable. So coaxial cable, the A dimension, B dimension, C is given. Here we are finding the magnetic field intensity only at the region number 3. We know there are 4 regions: region 1, region 2, region 3 and region 4. So here we are calculating only for region number 3, and the formula is I divided by 2 pi r c square minus r square divided by c square minus b square. With all the known facts A, B, C given, I have to find r is equal to at this point, because at the coaxial point I am going to obtain the magnetic field at this point of 0.01 comma 0 comma 0. So you take this as a first point minus center of the coaxial cable, which is 0 comma 0, which happens to be 0.01 square 0 square 0 square, and therefore r is equal to 0.01 meters. With the substitution, I can get H vector is equal to 50 A pi milliamp per meter. So this is the problem based on coaxial cable. Next is the problem based on vector magnetic potential. So A vector is given. I don't know what is A vector, but still it is Weber per meter. Since it is Weber per meter, A vector is equal to this amount. Therefore, it is nothing but vector magnetic potential in certain region of free space. Show that del dot A is equal to 0, and we have to evaluate A vector. A vector is already given. I have to find A vector at point P, B vector, H vector and J vector. We have to know the fact A vector is a magnetic field. If I take the dot on magnetic field, it will become 0. So if I apply the divergence, dou Ax by dou x plus dou A by dou y plus dou Az by dou z is equal to this amount, and therefore all will become 0. 0 plus 0 plus 0, it will become 0. So hence it is shown. Next thing is A vector. A vector is already given. A vector is already given. I have to substitute y is equal to some that given amount. Y is equal to -1. Z is equal to 3. X is equal to 2. Z is equal to 3. If I do those substitution, I will get A vector is equal to this answer. And next thing is we have to find the B vector. With the theory knowledge, we can write B vector is equal to del cross A. B vector is equal to del cross A. It is a cross product. Since it is a cross product, I can indicate the determinants. So determinants, if I expand this determinants, I'll get this equation. And if I expand this, I'll get this equation in AX direction, AY direction, and AZ direction. So therefore, further simplification, I'll get B vector. It is easy to solve. You can solve with help of this material. I will share the material to you in short while. And B vector is equal to this amount. So B vector is equal to 2 comma minus 1 comma 3. I have to substitute the x is equal to 2, y is equal to -1, z is equal to 3. If I do those substitution, B vector will become this value. So in the question, we should also find h vector. We know h vector is equal to b by mu naught. First you make divided by mu naught for this one. This is the first answer. And if you substitute with the same by mu naught, it will become a second answer in terms of ampere per meter. And B vector is in terms of Weber per meter square or Tesla. And finally, we have to obtain J vector. In unit number 3, it is a magnetostatics. So therefore, J vector is equal to del cross H. If it is a time varying concept, I can write del cross H is equal to JC plus JD. Since it is a static concept, J vector is equal to del cross H. So del cross H is known, cross product. So for cross product, we are going to do the determinants, expand, and if you do all the necessary derivation and substitutions, you will find J is equal to 0 ampere per meter square. So this is J vector value. Since J vector is equal to 0, at any point J vector will become 0. Next problem, we are finding H, they are given H vector. So the region is defined, rho 5 and Z. All three values are given. We have to find the scalar magnetic potential at the given point. The point is 4, 50 degree, 2. So here for scalar magnetic potential, the formula is Vm is equal to minus integral H vector dot dl. It is a known factor, known formula. So H vector is given. H vector is in A pi direction dot dl should be also in A pi. For A pi, the displacement is rho d phi. So if I make the dot A phi will become 1. 1 by rho into rho will become 1. D phi is alone of minus integral d phi. So the answer is minus phi. So Vm is equal to minus phi in general case. But I have to find the point at 4, 50 degree, 2. So at 4, 50, 2, it is a radius value, it is angle pi value, it is z value. Since pi is alone involved, it is minus 50 pi. If I want to convert to radian, I can put pi by 180. If I do that, the answer is minus 0.8726. Dear student, you should understand that I have shown some problems. You have to do the calculation with help of calculator. Please repeat the same thing with help of calculator. Do understand that it is just I am showing in the video, but still you have to proceed with this kind of problems. Next problem, a problem based on solenoid. Here the thing is, if I say the word solenoid, inductance is involved. So a solenoid has an inductance of 20 millihenry. If the length is increased, it is a kind of problem. The length is not given, but the length is increased by 2 times. Length is increased by 2 times, and the radius is decreased by half. Length is twice increased, radius is dropped to half. Therefore, we have to find the new inductance. So 20 milli is already given. I have to find a new inductance for the given structure. Therefore, with solenoid as an important material, we know the inductance of solenoid is mu n square A by L. So that is given as 20 millihenry. Therefore, A is equal to, since the solenoid has a circular cross section, area become pi r square. So this amount equal to 20 millihenry, equation number 1. Now, new radius is equal to old radius by 2. New length is equal to twice the old length. L dash is equal to 2L. Now the new inductance will become mu n square pi R that is R by 2 square 2L. With this substitution, R as R by 2, L as 2L, I'll get equation number 2. So 1 and 2, divide 1 and 2. So 1 by 2, which happens to be L by L nu is equal to 8. Therefore, the new inductance is equal to L by 8. Already old inductance is 20 milli by 8. So therefore, the new inductance is 2.5 millihenry. So that is given. The last problem of this session is a solenoid is defined of 50 centimeter long, 2 centimeter dia and contains 1500 turns. A cylindrical core has diameter of 2 centimeter and relative permeability of 75. This coil is coaxial with the second solenoid with 50 centimeter long but 3 centimeter dia and 1200 turns. All these 4 lines as drawn here. So inner solenoid, outer solenoid. So both the length are 50 meter. One is 2 centimeter dia, the second is 3 centimeter dia, and turn is 1500 and 1200. So with this given dimension, we have to find individual inductance L inner, L outer, and mutual inductance. 3 parameters. In order to find the L inner, we know the formula for solenoid. It is mu n square A by L. So all the values are known. Mu substitute mu value, n value, all the value. You will get L inner is 132.2 millihenry. That is the first answer. Second answer, L outer. If I take the second solenoid, the first solenoid is also coaxially within. So we have to take combined effect. So therefore, L outer is equal to inner plus outer. Inner plus outer. For inner, A is equal to pi inner radius. What is the inner radius? 2 centimeter is dia. Radius is equal to 1 centimeter. 1 centimeter is nothing but 0.01. So pi 0.01 square happens to be 3.14 into 10 to the power of minus 4. For outer, we have to take this amount. So totally 3, it is 2 and it will become 1. So it will become 1. So if I minus this, it will become half. So it is 0.015